Good evening, everyone, or good morning, or good afternoon, wherever you are in the world. My name is Alvin Chin. I am the chair for the IEEE Vehicle Technology Society Industry Engagement Committee. So this is a VTS industry webinar that we have today. And I'm also the chair for the IEEE Vehicle Technology Society Chicago chapter 2 as well. And we're pleased to this evening have Avad Nagarawala, and he's going to be speaking on electric rope shovels, history, product overview, and technology. So just before we start, just a little bit about the Chicago chapter, VTS. You can go to IEEEchicago.org/VT. The Vehicle Technology Society is at vtsociety.org. So if you are members of the Vehicle Technology Society, you're familiar with this. So like I said, I'm the chair of the Chicago chapter. I was actually formerly a research scientist at Discovery Partners Institute. I'm now actually an adjunct assistant professor at University of Illinois, Chicago, teaching in the School of Business. Our vice chair is Kevin Studenberg from Argonne National Laboratory. Our IEEE Young Professionals VTS student chair is Juru Chen. And the VTS Chicago chapter, the mission is to create a community of academics and professionals interested in vehicle technology and engineering the vehicle to create connected vehicles and autonomous vehicles. The topics that we discuss about in our meetings are vehicle ad hoc networks, 5G, autonomous, connected, and electric vehicles, cloud, connected vehicle platforms, smart cities, etc. If you are not a VTS member, you can go to vtsociety.org/engage/membership. And we are also on social media there as well. So you can go ahead and record this. This talk is also being recorded too as well. So you'll get a copy of the recording when this is ready. And for the Industry Engagement Committee, so I'm also serve as the chair too as well. And basically what we do is that we are helping to connect professionals to IEEE Vehicle Technology Society. You might be familiar with Vehicle Technology Conference. So we help to actually also organize industry panels in the conference if you have attended a VTC conference. Also what we do is that we provide input on how to improve industry engagement in VTS to the VTS Board of Governors. So regularly, usually 2 times a year or so, myself, I will report about what we have done for VTS Industry Engagement Committee back to the Board of Governors. If you want more information, you can go to vtsociety.org/committee/industry-engagement-committee. If you want to be a part of that committee, you can go ahead and email myself. You will find it in the website there, or email me at alvin.chin@ieee.org. Also, as well, like I mentioned earlier, Vehicle Technology Conference. So there's one happening in October in Chengdu, China, from October the 19th to 22nd. And so right now they're looking for industry panel proposals. So if you have an industry panel that you would like to propose and you have some panelists that can go ahead and participate in a panel, you can go to this website and you can make a proposal if you wish to do so. Oops. Okay, great. So yeah, without further ado, then I'm going to hand it over to Avad Nagarawala, who is from Caterpillar, to go ahead and start the presentation. Thank you.
Perfect. Thank you. Thank you so much. Let me start sharing my screen. Can you see my screen?
Yep. Yes, we can.
All right. First of all, good evening, good afternoon, good morning, wherever you are from the world. Thank you for joining today's IEEE VTS webinar. My name is Avad, and I'm from Caterpillar. And I'm excited to present today on the topic of which is kind of a very, it's kind of a one of the topic which is kind of one of my heart of the professional journey, which is electric rope shovels. These electric rope shovels, uh, I'm going to talk about history, product overview, and technology advancement. So today, over the course of this session, I will I will walk you through the evolution of these machines, highlight how they have transformed mining operations, and over the decades, I will try to provide some kind of technology advancement on these machines. So as you can see on this right side, that is a electric rope solve machine. At the end of the presentation, we will have some question and discussions. I'll try to take your questions, but in case if I am not able to take all of your questions, please note it down my LinkedIn link, and you can always send a message on me on my LinkedIn profile. So with that being said, let me go to the next slide. So here is how we will navigate to this presentation. First of all, I'll go with a brief history about these electric rope solve machines, where they came from and why they are so important. Then we will go to these ERS machines components, kind of a product overview. What are the different motions and what are the different components? And then we will have a closer look on electrical and mechanical system of these machines. And then after we will go to the technology advancement, such as operator assist, cycle segmentation, condition monitoring, which are kind of crucial for improving the efficiency of the machine. And finally, we will have some kind of summary with the key insight before we open the floor for question and answer. So now, first of all, a brief history. So the first drop shovel machine, which was kind of a steam powered, that was built in around 1910. So I would say more than 100 years ago. At that time, Bucyrus was a company who built this kind of machine, and the first model was 120B. Then after there was a kind of some changes has been happened, and then Bucyrus 95 was built, and that was a kind of used in a landmark project such as building a Panama Canal, in 1914. In 1917, the Bucyrus became the first company to introduce electric motors to this rope solve machine. So today we have a lot of discussion going on with electrifications or electric vehicles, but at that time Bucyrus, about 100 years ago, they have already introduced electric motors into these steam powered machines. And then so these are the different models which were kind of previously used before Caterpillar bought a Bucyrus. So in the around 2011 2012 timeframe, Caterpillar bought a Bucyrus, and all the electric rope shovels are now managed by Caterpillar. I'll go with the some of the shovel components, motions, and product overview. So here is a quick look of the Caterpillar 7495 electric rope shovel machine. Now, just to give a little bit of idea how this machine, I mean, what is the size and height of this machine. So the total height is about 68.3 feet. If you compare this height with any other living object, it is almost the size of the big high-rise building. So that's a kind of, that's how, this is the statistic ideally. This is the size of the height of the machine. It's pretty huge mining vehicle. If you compare the length of the machine, that's almost a size of the one aeroplane. That's a length. And then width of the machine is about 42 feet. This machine is about 3 million pound. That's the weight of the machine. If you compare with that's kind of equivalent to 1,300 cars combined. This machine has a payload capacity, which we call as a dipper capacity. It's about 120 tons. depends on the configuration as well. These are not just about the statistics. Ideally, they highlight the kind of scale of the mining operation, because these machines play a very big role in open pit mining or surface mining. Now we will go to the different components or different section of this machine. So basically every giant machine, that is from the key building block, right? The upper works as example. These upper works, as you can see over here, that has a hoist, crowd, and swing assembly, which is kind of a rotating the, which is kind of a moving the machine in a different direction. Then we have a lower works, which is kind of connects the motion to the machine. If you wanted to travel the machine, or if you want to propel the machine, then there is a lower works. And then there is a swing auxiliary. If you want to rotate the machine at 360 degree, then there is a swing machinery over here. And at the heart of all of its all of this component, the main component is operator cab, which we call it as a op cab. Traditionally these machines kind of or I would say historically, these op cabs are kind of was physically demanding, and mentally exhausting as well. Because if operator, most of the mine site right around the world, these operators works 12 hours in a shift. If the machine operating practice, if they have to do the same repetitive task for 12 hours, it's kind of mentally challenging and physically not sufficient, right? So in that event, right now with the use of technology, these op cabs are pretty much ergonomic comfort. It can provide good comfort and precision control. So, and I will have some more slides with this operator cab, but this is from there they are operating the machine. Since the size is the big, they normally use a joystick, digital joystick, to move the machine and to use the different motion of the machine. This is one more slide with the operator, and this is just kind of a the operator, as you can see over here. Operators are kind of there is a 3 seats over here, one for trainer, one for touchscreen display, where they can use the touchscreen facility of the machine, and there is some observation seat over here. Now moving towards the major shovel motions. It's to understand how machine works basically. We can break it down in a different motions of this machine. So the first one is a propel motion. As you can see over here, propel motion is kind of moves the machine forward or backward. Or I would say in a layman term, it allows machine to travel. So with the use of digital joystick, they can propel the machine. Then there is a swing motion. So swing is rotating the machine. So with the use of these crawlers, they can rotate the machine 360 degree in either direction. And then there is a crowd motion, which kind of moves the dipper into the bank. So this is a dipper, and that with this particular motion, they can move the dipper into the bank. When they are kind of extracting the dipper, we call it as a crowd. When they are retracting the dipper, we call it as a retract motion. And then there is a hoist and lower motion, which is kind of a lifting the dipper and lowering the dipper. Each of these motions, ideally, that is electrically driven. So those are electrical driven, synchronized, and I would say designed for efficiency. And they all of these motions form a heartbeat of the mining operation. These are the different models currently Caterpillar offers with the change in dipper capacity. So we have ideally 2 different models for ERS machine. The first one is a 7495 HD, which has about 90 tons of dipper capacity. So in one particular pass or one cycle, this machine can extract about 90 tons of material. Then we have another model, which is a 7495 HF, or 7495 standard, which has about 120 tons of dipper capacity. And this is just a kind of loading pump system match. When we compare our ERS machine, which is electric rope swell machine, we compare it with the different size of the mining trucks. So all of these you can see this numbering, right? 770, 772, 798 AC. So those are the truck models, mining trucks. So how we compare it, that in how many pass or how many cycles this machine can fill up the whole truck. As example, if I can take example of this 7495 ERS machine, so we can say that in 4 passes, it can fill up the largest mining truck in the world, which is 798 AC. So machine has to rotate 4 times with the material to fill up the whole truck. And now this truck has a capacity about 400 tons of material. So it can carry about 400 tons of material in 4 passes. And that's how we compare with our competitor mining trucks as well. Now, let's go to the electrical and mechanical system of this machine. So, most of the large mining operations distribute power at voltage greater than 110 kV. So this 110 kV voltage is getting transferred, or I would say step down to the field switch house with 6 to 13 kV voltage, and that is pretty much sufficient for electric rope swell machine, because this machine has it can run on 7200 voltage capacity. So it will require 7200 voltage to run the machine. Now, most of the many of the mines, they have a diesel powered machines. Now the benefit compared to diesel powered is that if you have a continuous electric supply, then you don't need to always stop the machine for refueling or for maintenance, because this electric machine, ERS machine, that can run 24/7. So in some of the mines, I have been to a few of the mines, and I have seen that these machines work 24/7, and it can extract a pretty good amount of material within a day or within a month. Of course, those are energy efficient compared to diesel hydraulic machines, and sustainability and reliability is always good with these ERS machines. This is just a kind of electrical power flow, how we are feeding the electric supply to the machine. So as you can see over here, first of all, the voltage is coming through to the machine, to the back side of the machine through trail cable. Now, if you have noticed that in my previous slide, this is a trail cable. So in the trail cable is passing to the back side of the machine. So this trail cable, now the trail cable is kind of passing going to the high voltage collector rings. The collector ring, what it does, that it allows the machine to upper structure to swing 360 degree, because without collector ring you cannot rotate the machine with the power cord, right? And that will make sure that uninterrupted power electrical system or electrical connection rotate gives to the machine. Then this power is kind of first received by this high voltage collector ring, and then we with the protection and isolation, we give it to the dry power transformer over here, where it is stepped down. So with the dry power transformer, it is stepped down, and then we are feeding that to the motion regulator cabinets. Now this MRC, that is the brain of the power distribution, ideally, because it distributes and loads, balances how much power is delivered to each of the motor. Now with this machine, we have different kind of motors, and I'll go to in my next slide, I'll go to the different size of the motor. So this MRC, it feeds to the power to the different motors. As example, this is a hoist motor. As I was mentioning in my earlier slide, that hoist for hoist motion, there is a hoist motor. Then there is a crowd motor for crowding and retracting the motions. And there is a two swing motors. So swing motors are kind of rotating the machine in each direction. And then there is a propel motor, which is kind of a traveling with the propel motor. Machine can travel either forward or backward. And then we have a auxiliary power transformer. Basically, that auxiliary is kind of is feeding the power to the critically secondary system, basically, whether it's blowers, cooling fans, pumps, or lighting, or PLC cabinet. So this auxiliary power transfer feeds to the different components. And then we have a motor control center, and then there is a main PLC cabinet. So this PLC is kind of a brain of the machine. With the use of PLC control system, we can operate the machine with the use just with the control system design. Now, while the electrical system provides the energy, the mechanical systems are where the energy is translated into the digging power. So let's have a look on some of the mechanical system. So as you can see, hoist system, right? So hoist has a kind of the motor size is 2600 HP motor. So that is a pretty huge motor, and it has a massive drum. So what that motor rotates the drum for the hoist rope, because there is a rope is kind of pulling the hoist system. And it can lift up to 120 tons of payload, with controlled acceleration and braking. We do have a crowd motor, which has a capacity, which is for a 700 HP motor, and that is, that has a parallel shift gearbox, which is again there is a gearbox attached, and to rotate the large crowd drum. We do have a two swing motors with the size of 500 HP motor. That is again with for the rotation, and that has a planetary gearbox attached with it. And we have a propel motors with a 700 HP in the size. Now I would like to start a video where you can see the while the machine is in operation, how it dig the material and how it transfer the material into the mining truck. So as you can see over here, currently machine is digging the material, and then now it's swinging towards the truck. And now in this pass is about 120 tons of material has been extracted, and it is dumped into the truck. Now again it is swinging back toward the bank, because this digging phase we call it as a bank. So now machine is, if you have seen that, now machine is lowering the dipper handle. At the same time, it is crowding the machine, and it is it is digging the material and swinging towards the truck again. So this is the normal. And if you notice that there is a bus over there on the back side, on the back end, it's pretty small bus over there, white color, but you can see the size of this machine. It's pretty huge mining vehicle. Now I will go to some of the technology advancement, and that is where I would like to talk a little bit more about what kind of new technologies have been implemented on these machines. First of all, operator assist. So operating this machine is kind of it's kind of art and science, I would say, because even sometimes I have seen that some of the high skilled operators they face challenges with the controlling this machine, because the payload capacity is pretty high, and they wanted to make sure that cycle time, pass count, there should be a standardized process for that. and of course they need to make sure that the machine doesn't have enough. It's protecting the machine from stress. So that's why we have this operator assist system. Because we use some kind of algorithms, sensors, and control logic to support the operation in real time. And some of the key examples I can show you in the next couple of slides. So one of the example is the swinging in the bank. So if you have noticed that the graphic on the left, there is a effect of swinging while engaged in the bank. So in ideal terms, if your dipper is in the bank, or if you are when you are digging the material, you should not swing the machine. Sometime if the operator doesn't have enough training, or if they might not have enough knowledge about operating the machine, many times if they are trying to swing the machine when the dipper is engaged, then it can cause a lot of damage to the machine. And with those kind of damage, it's a pretty huge amount of its dollar amount would be a little bit not little bit, too much higher if there is a damage on the machine. So to avoid this kind of situation, we have developed a feature in which we wanted to make sure that we are kind of remotely controlling the machine. We wanted to make sure that machine that should not swing while it's engaged in the bank. So that we call it as a swing assist system. It can reduce the high stress result from swing torque, and it act against the dipper, and further produces the significant stress to the pedal block. With this kind of system, of course there is a prevention over swinging or under swinging, and which is both of waste of energy and extend cycle time. So that is one of the feature. Second one would be if you can see this hoist rope slack prevention, or I would say boom jack minimization. So again, when the operator is operating the machine, we wanted to make sure that there is a rope attached over here. If you have noticed that, we don't want any slack in the rope, because if there is a slack in the rope, then it can there is some procedure they have to do it, and it can extend the cycle time of the machine, it can reduce the productivity of the machine. So to avoid this kind of slacking into the rope, we have develops technology so that operator can have a it can avoid slacking into the rope, and it again is it assists system automatically adjust the motor torque to keep rope tension consistent and preventing the slack. That is again the one of the tool. And together I would say that these tools don't replace the human judgment. Basically, instead of that, it acts like a co-pilot, or enhances safety, extending the machine life, and letting operator focus on productivity rather than they have to constant correction. And in a simple terms, I can say that operating this kind of machine is like a driving a car, right? If you are driving, think about a modern car, whether it's Toyota or Honda or any other car. Those cars have adaptive cruise control, collision avoidance, and all kind of different technology. So they don't replace the drivers, but they make driving more smoother, safer, and less tiring. So it's a similar concept of using operating these machines as well. Now the next one is a cycle segmentation. So cycle segmentation is again one of the most powerful digital tool we have introduced in recent years. So every before cycle segmentation, what happens that every digging cycle, um, you know operator has to log all the data manually. Basically, with the cycle segmentation, what we try to do that we break down the distinct phases, whether it's crowd, swing, or hoist motions, and then we calculate how much productivity machine have done during certain period of time. So as example, by breaking down the cycles down, or mining customers, they can easily identify whether an operator is losing efficiency, or if there is any training or knowledge exchange required for the operators. As example, if you have noticed that this cycle sends the data, right? We are feeding to the somewhere remote server, and then we provide those data to our customer, and they can take a better business decisions, whether they have to focus on certain areas, whether they have to some kind of make the changes in the mine operation. So that is pretty useful tool, and it is kind of set a benchmark and best operating practice, because it enhance the operation efficiency, improve equipment productivity, of course real-time data monitoring and insight, and predictive maintenance as well. So this as you can see, there is a widgets over here, which based on the size data, it can provide a widgets in a graphical user interface, and someone can have a look on those data, and they can take it, they can take a better decision about mine operation. And I would always compare this cycle segmentation as a kind of similar to using a fitness tracker, right? As example, when you exercise, or kind of when you always wanted to capture that how many miles you have, how many calories you have burnt it, or how many what kind of intake level you have to take it for protein, etc. So this is again the same kind of concept over here. Now again, this is one of the example. This is how cycles we counted cycle segmentation. As you can see, currently machine is kind of digging into the bank, and that is, we call it that we I classified as a dig, and then it will swing and dump. I'll go to the next slide. This is a kind of a condition monitoring system. This condition monitoring is kind of a, it takes a predictive capabilities a step further. So instead of just tracking what the operator does, right, it tracks the health of the machine in a real time, basically. So these 7495 ERS machines, they are equipped with good sensors, data loggers, and onboard diagnostic system. That monitor everything from the vibration to temperature and torque of the different motors or any other components. So some of the critical examples, motor health, or ropes and gears. So this sensor measures the vibration level on different machine component, and it can give a proactive maintenance. It can give kind of notification if there is anything is going to fail or anything is going to break. It's a kind of proactive maintenance of gear case and motors. Of course, it reduces the downtime from unplanned machine outage, right? I mean, if you know well in advance that something is going to break, definitely you can take a preventive measurement or preventive actions. Cost reduction is always one of the system benefit, safety enhancement, and improve operational efficiency. On the right side, you can see there is a chart, or I would say that is a graph. That's how we measure that how much what kind of vibration is required on particular component, and based on those data we can provide we can guide our customers about different if there is any vibration level is exceeds out up to certain level or not. Now finally, I'll summarize with what kind of what we are trying to achieve. So we are trying to solve the right problem with the right way, with either cycle segmentation, where we are optimizing the efficiency, or whether condition monitoring system, where we are kind of taking a proactive maintenance of the machine, or operator assist with enhanced safety and precision. So we wanted to make sure that we provide a better better value of this machine by introducing technologies, and how we can make it mining operation more smoother and innovative with this kind of technologies. With that being said, I will open the floor for questions, and any questions or any discussions if someone wants to have it.
Yeah, thank you very much, Avad.
Mhm.
I think there was a question. We'll start with a question in the chat, and then others, you can raise your hand or unmute to ask your question. So Bruce asks here, are the mining trucks electrically driven, batteries or motor generators?
Mining trucks, there are some of the mines in the world. Where some of the pilot projects are going on with electric mining trucks, but that is under, that has been there, but I'm not sure how many mines or how many mining trucks are kind of electric mining trucks. But yes, there are certain mines which does have electric mining trucks.
Okay, great then. Thank you very much, Avad. Any
Mhm.
questions from the audience? You can type in a chat or unmute yourself.
A question from the audience. Can you hear
Yes.
me? Am I great?
You are audible. Yes, go ahead.
Excellent. Thank you. Question for you. This may be a little bit off topic, but there's a lot of talk about resource utilization on the moon. And I'm wondering if any of that has actually reached the Caterpillar company, because it seems the designs of this type of equipment, which is very exotic, or well, it's very sophisticated, gravity plays an important role. And when gravity is not at 1G, but at 1/6 G, how does that change the design of the equipment?
Um, to be honest, I don't have any visibility about that kind of, any discussion is going on. Because again, these machines are, yes, these are pretty huge mining vehicle, and when we need to put it into the mine, it required a lot of efforts, and a lot of efforts are kind of needed. So I I I don't have visibility about mining onto the moon. That is I I don't I don't have any idea about it.
No problem. Thank you. That's all.
Yeah.
So there's a question from Harry in the chat that says, how do you manage and protect the electric supply cable during machine movement and operation?
Right. So when we talk about trail cable, those are pretty rugged trail cable, and we have good amount of protection for those cable. So when we are feeding huge amount of power to the machine, and that is something most of the mine companies they do, that they provide enough protection for those cables. And these mine sites, they are kind of in a very protective. There is a lot of restrictions are there. Any individual, if someone wants to go to the mine, they had to complete some kind of courses, some kind of training supposed to be taken. So with that being said, trail cable access or trail cable, that is one of the question. When you go through the technical training, then what kind of actions you have to take it, how you protect yourself by not touching any of these areas. But it's a pretty protective atmosphere environment, and they do take care of very nicely about those trail cables.
Okay. Maybe I can have a question to ask you, Evan. So maybe two questions to ask. So first of all, first question is that for these electric rope shovels, is there any type of AI that's being used within the electric rope shovel itself?
Um, I I personally don't have any kind of visibility about AI using,
Okay.
because AI is, um, I I don't have any idea about any of the AI has been implemented on any of the ERS machines.
Okay. Okay. And I guess another question is that maybe you probably already cannot answer this, but do any of these rope shovels are any of them autonomous, like vehicles, or you need to have someone to operate them?
Most of the currently most of the rope shovels, those are kind of manually operated. So you need someone as operator to operate those machines.
Okay, great.
Yep.
Thank you.
Mhm.
Any other questions from the audience? You can unmute or raise your hand.
I guess I have a
Okay.
question.
Go ahead. Go ahead.
On the motion, it looked like the retracting crowd kind of was happening at the same time as the hoist. Are those coordinated motions where you have to like pull in on retracting crowd in sync with the hoist to get the motion you want, or do you just do one motion at a time?
No, so ideally, when you are hoisting, when you are crowding the machine, right? And I can play the video again. Give me a minute. All right. So if you have seen this video, when the machine is, if you see this one, it is kind of a crowding, but at the same time it's hoisting the machine. So these ropes are going up, which is kind of hoisting the machine. So crowding and hoisting are happened at the same time. And when the operator is kind of swinging the machine, it is retracting the machine. So, it's kind of crowding and retract cannot happen at the same time, but crowding and hoisting or crowding or retracting and lowering, those are the different combination can happen at the same time.
So that's where the skill of the operator comes in, that he has to
Yes.
control two separate motions simultaneously to keep the pattern in play.
Yeah, and there is a dedicated training programs, and best operating practice has been given to the operators so that they can properly operate this kind of heavy machine. Because if you are not operating properly and if you're damaging the machine component, then it's going to cause a lot of money to the mining customers and mining clients.
I guess a follow-up question on that would be, do they have things like a flight simulator where they practice the motion on a digital version of the device before they get on the real machine, or is it a really learn on the job thing?
Most of the mining companies, they have a dedicated infrastructure. Whether you can think about any of the mining customer, they do provide some kind of technical trainings to the operators. Now, I'm not sure what kind of form they have it, whether they have a simulation or whether they have any particular model, but they do provide good extensive training to their operators.
Okay, thank you. Any other questions from the audience? Or you can also type in the chat too as well. Maybe a question that I have for you, Avant, is that are there any competitors to what Caterpillar has on the electric rope shovel? Just curious to know.
Yeah, there are good amount of companies. They compete with ERA with Caterpillar on ERS machine. Komatsu is one of them, and then there are a few other companies as well. So there is a good amount of competition with this kind of machine.
And what would you say is like the uniqueness or so, because there's so much competition you mentioned just earlier. So what is the kind of unique competitive advantage, in your opinion, in terms of Caterpillar's implementation?
There are several advantages because Caterpillar is a big brand, right? I think it's a so we are kind of producing these machines for about 100 years ago, right? I mean, since last 100 years. So there are definitely a good benefits. As of now, the biggest advantage I can think about is op cab, because we have a good design of operator cab compared to our competitors. So that is one of the advantage I can think about it. But when I talk with commercial team or people who are more familiar on sales, they might, I think, give good discuss good points about or good idea about what are the different competitive advantage. I have most of the time I have seen CAT ERS machines, so I'm not sure what kind of what kind of other benefits our competitors are providing to with these machines.
Okay, great. Thank you.
Mm-hmm.
Any other questions? We still have another maybe 5 minutes for questions.
One question from my side. So does anyone have ever experience about mining? Anyone have ever been to any mine site, or if they have seen any kind of mine operations anywhere earlier?
Yeah, I've been on a sort of tour of a smaller strip mine where they were using a hydraulic version of this kind of shovel rather than the rope operated. It was a hydraulic arm, but a similar digging motion. We
Okay.
owned some property that was strip mined in the 80s, and I've seen some equipment in operation there.
Okay. Yeah. So there is a hydraulic mining shovels are also there, which are operated through hydraulic system. And of course, you would need refueling or diesel cap. Those are kind of hydraulic operated. So you would need some kind of refueling, some kind of material, right?
Yeah.
That's the benefit of this ERS machine, that you just need a continuous power. You need continuous electricity.
Yeah, the machines I saw were smaller scale than this, and they were diesel.
Yeah.
I've also seen in the Terre Haute area here in Indiana, they used to operate a drag line, which was a similar machine, but it dug in
Yes.
the opposite direction. I've seen that in operation as well.
Yeah, and drag lines are pretty big in size. They are pretty huge machines. We do have I do work with drag lines. I do have a good amount of experience with drag line machines as well.
Yeah, and our property in the 40s was mined with the drag line, and in the 80s it was done with earth movers rather than shovels like this. But I've seen a more recent mine nearby operating with the hydraulic shovels.
Okay. Yep.
So about how often does this electric rope shovel, this product, get like refreshed? Like, I mean, I assume that because since it's already built or so, unless you really need to like modify something significantly or so, it would stop probably, many years or even tens of years, right? That can still be in operation. Like how many different kind of versions, or how many types of, due to like the technology or so. I assume that doesn't get refreshed very often, right?
Yeah. So basically, most of the mine, as example, if there is let's assume that there is a mine in Mexico, so they have a contract from government about operating that mine for 100 years or 90 years, right? So these machines, it depends on the customer to customer, that how many years they wanted to keep this machine, or how they are operating the machine. Because at one point of time, these machines also have some challenges. When they are operated at certain years of operation. So it all depends on customers to customer. Whether some customer might be running this machine for 20 years, and some customers are keep running for 40 years. um, um, and it depends that whether mine is operating, because some of the mines, they might have permission to operate for certain years, and then they stop the mine, park the machine, and then they start the mine again. So ideally, it's hard to say the lifetime, or lifeline of this machine, but um, that is just a kind of one example that it can run up to, depends on the operation of the machine, basically.
Okay. And I think we
Yeah.
have a comment here in the chat that says here that those machines must require a lot of power, and then the distance of the power cable device to source must cause some additional engineering work, especially as a cable.
Yes. So yeah, most of the mines, they before before they start production or before they start digging the material, they will make sure that they have enough electricity. And some of the mines, I have seen that they do build a separate powerhouse near to the mine, so that, and this mine operation is pretty huge operation. So normally what they do, that if they are going to open a mine, they normally kind of build a new village over there, so that they can people can stay nearby village, and they can have a good electricity, and all the all the equipments, or all the kind of whatever they needed, they can get it easily. So yeah, to add that point, yeah, electricity is one of the crucial component to operate the mine. And that's before they start production, they make sure that there is a good amount of electric connectivity is there.
Great, thank you. Harry has a question, that how does Caterpillar and the owner go about delivering and installing a new shovel at a mine?
Yeah, so most of the time what we do, that we commission the machine at the site, because we cannot move the whole machine from one location to another. We break down the component, and we deliver those component on the mine site, and then that's where we build the machine. And I think most of the ERS machines are built in such a way that whether we or or our competitors, they build the machine on the site itself. So we cannot take the machine from one location to different. We just normally put it all the components at one site, and within a mine site, of course, with the use of propel, they can they can move the machine, but that can be done within a mine site only.
Can Caterpillar, I know Caterpillar, has like a data science kind of, division or so, looking at, the data of their kind of, machines and their operations. Does there exist also as well, some type of, data that Caterpillar collects, from these electric rope shovels when they are in the use of for the clients, so they can see, how it's being operated and when maybe it might need to be repaired or fixed?
Yeah, so we do have some kind of agreements, or some kind of NDAs signed with our customers or with our clients or partners. And if we are collecting the data as example, and again, that is a dedicated team for that, because my work mostly on the engineering side or technical side. But there are some kind of agreements between the Caterpillar and the client. And if there is agreement, then they will get the data and provide the data accordingly.
All right, thank you.
Yeah.
Anybody else have any last questions for Yvonne before we can finish off with some concluding remarks? Any other further questions? Okay, if there are no other further questions, thank you, Avad, for the presentation. I'm just going to go ahead and kind of end here to let you know that we have another presentation, part of the VTS Chicago chapter, but any VTS member can also join here too as well. I'll put this in the chat if you want to register for this event. There it is. And basically, this is we have a graduate student, Nicholas Corsini, in computer science from the Illinois Institute of Technology, and he did a project. Actually, I was also one of his co-supervisors on this. So he's going to give a project talk on the future of ambulance detection towards safer roads and smarter travel. So if you're interested, go to this website, and then you can register on Zoom at the link there that you see in the on the screen. And that is next week. So that is a week from today. So it's Tuesday, August the 26th. Note the time change. So it's not at 6 p.m. in the evening. It's going to be at noon. So it will be a noon webinar. So if you're interested, you know, I put the link in the chat, so you can go ahead and register for that. All right. There's no other further questions. Thank you, Avad, for this wonderful
Sure.
presentation. Thank you all for attending this evening for our IEEE VTS industry webinar. Our plan is to have more of these on a regular basis, possibly maybe quarterly or so. And we'll have other industry speakers too as well. So stay tuned. And if you have any particular, want to suggest any particular speakers for a VTS industry webinar, you can email me. I'll put also in the chat too as well, alvin.chen@IEEE.org. And then we can also set one up too. Or if you want to speak to as well, you can also let me know as well.
Sure.
All right. Thank you everyone for
everyone.
attending.
Yep.
Thank you everyone for attending. And I wish you have a great rest of your evening.
Thank you.
All right. Thank you, everybody.
Yep. Bye.